Welcome to this course on the Farm Stack and FastAPI. I'm Bo Carnes and I'll be teaching this course. The Farm Stack is a modern web development stack that combines four powerful technologies: FastAPI, React, and MongoDB. This full-stack solution provides developers with a robust set of tools to build scalable, efficient, and high-performance web applications. In this course, I'll be giving you an introduction to each of the key technologies, and then we'll build a project using the Farm Stack and Docker so you can see how everything works together. Feel free to skip ahead to any section you are most interested in. The Farm in Farm Stack stands for FastAPI, the backend, React, the frontend, MongoDB, the database. The Farm Stack is designed to leverage the strengths of each component, allowing developers to create feature-rich applications with a smooth development experience. Now I'll give you an overview of the components in the Farm Stack. FastAPI is a modern, high-performance Python web framework for building APIs. It's designed to be easy to use, fast to code, and ready for production environments. FastAPI is built on top of Starlet for the web parts and Pydantic for the data parts, making it a powerful choice for building robust backend services. React is a popular JavaScript library for building user interfaces. React allows developers to create reusable UI components that efficiently update and render as data changes. Its component-based architecture and virtual DOM make it an excellent choice for building dynamic and responsive front-end applications. MongoDB is a document-oriented NoSQL database. It stores data in flexible JSON-like documents, meaning fields can vary from document to document and data structure can be changed over time. And also, the MongoDB company provided a grant to make this course possible. Let's discuss some of the advantages of using the Farm Stack. First, high performance. FastAPI is one of the fastest Python frameworks available, while React's virtual DOM ensures efficient UI updates. MongoDB's document model allows for quick reads and writes. Scalability. All components of the Farm Stack are designed to scale. FastAPI can handle concurrent requests efficiently, React applications can manage complex UIs, and MongoDB can distribute data across multiple servers. Then there's the community and ecosystem. All three technologies have large, active communities and rich ecosystems of libraries and tools. Flexibility. The Farm Stack is flexible enough to accommodate various types of web applications, from simple CRUD apps to complex data-intensive systems. So by combining these technologies, the Farm Stack provides a comprehensive solution for building modern web applications. This stack is particularly well suited for applications that require real-time updates, complex data models, and high performance. As we progress through the tutorial, you'll gain hands-on experience with each component of the Farm Stack and learn how to integrate them effectively. Before we combine the technologies together, let's talk about each individually a little more. I'm going to show you how to set up a super simple API using FastAPI so you have a better understanding of how it works. Later, we'll create a full to-do application using the Farm Stack, and we'll be using FastAPI to create a robust backend API. We'll define routes for creating, reading, updating, and deleting to-do items and lists. We'll use Pydantic models to ensure data consistency and FastAPI's automatic documentation to make our API easy to understand and use. So let's build a super simple FastAPI project so you can understand the basics of FastAPI. This won't use any of the other elements of the Farm Stack, but once you see this, you'll have a better understanding for the context when we build our full Farm Stack application. So again, this is just a super simple FastAPI project, and the code comes from the official documentation, and this is what they recommend as your first project. So first we're going to install by pip install And then we're going to put FastAPI standard, and we want to put quotation marks. Depending on your terminal, the quotation marks may not be required, but sometimes they are, depending on how you have your terminal set up, and it always works. So then you can make sure if you put the quotation marks around it, it will always work. You could also do FastAPI all inside the brackets if you want all the features instead of just the standard features. So once we have that done, we can create our file, which is we're just doing a simple file. So we're just gonna call this main.py. So first we import the union type from Python's typing module. Union is used to specify that a variable can be of multiple types. In this case, it allows a variable to be either a string or none. And then we obviously need FastAPI, and then we create an instance of our FastAPI that will be used to define the API endpoints and their behavior. Then we have this section that defines our route for the HTTP GET method at the root URL, and it's just going to return a JSON response with the content hello world when the root URL is accessed. And this code here is going to be a different endpoint, which is going to be /items, and then it's going to have a query parameter, which this query parameter, the item ID has to be an integer, so it could be like item/1 or /2. This read item function is going to get the item ID, and then this where it says Q here, that is an optional query parameter that can be a string or none. It defaults to none if it's not provided in the request. And then we're just going to return a JSON response containing the item ID and the value of the query parameter Q. So this basically demonstrates the use of path parameters and optional query parameters. And that's all we're going to do for our server. We can actually just run that server in our terminal. We're going to run our FastAPI application with UVcorn, with a UVcorn server. So let's install that. Pip install UVcorn. Okay, now we can do UVcorn main, that's the main.py, and then I'm going to do main app, and then I'll do reload. And the app corresponds to the app in our file here. Let me just make sure that's saved. Okay, so now I'm going to go to this URL, and we can see it says, hello world. Now I'll go to the other endpoint, so I'll do /items/6, and then I can put a query parameter, because that got set up, and the Q equals yo. And then let's see what happens. Okay, so we have the item ID 6, the query is yo. So we got that server set up. Both paths take the get operation, but we could set it up to be post or put or delete or any of the other operations. But now let me show you about the interactive API docs. It's something really cool in FastAPI. So I'm just going to go to /docs, and then we see this API docs that are created automatically. So we have our root path that's going to show information about the response in the root path, and then we have the /item/item ID. We can see it's going to take an item ID and a query, an optional query parameter. So this is pretty cool that it's going to create all this for us. And then we can even see the full schemas for our API. This is all provided by Swagger UI. So there's different ways to view docs. So this, like I said, this is the Swagger UI, but if we go to /redoc, we'll see the documentation provided by Redoc. It's just a different way to show the documentation for API, including both the root and then the item with the item ID and the query parameter. So let's now do a little upgrade to our application. We're going to modify this to receive a body from a put request. So first, I'm going to make sure I also import Pydantic, or from Pydantic, I'm going to import base model. and we'll declare the body using standard Python types thanks to Pydantic. So first we'll create a class item that's going to have the name, which is a string, a price, a flute, and isOffer, which is going to be a Boolean, but it can also be none. And then, so we have the GET request for an item. Now we're doing the PUT request for an item with the item ID. So this is going to allow us to update an item with the ID and then put in the item information. And it's going to return the item name and the item ID here. So if I save this, it's going to update automatically. I can go right back over here. I'm going to go to Docs. And then you can now see this PUT request here. And it's going to have information about what we're putting for the PUT request. The item ID and then the request body. We have the example schema with the string, the price, and the isOffer. So we're going to actually go to the top here where it says try it out. And so I'm going to put item ID 1 and I can update this. Offer or item unicycle price 100 isOffer true. Then I can just click the execute button, execute. And so it sent the parameters, and now we can get the results and see the results on screen. So we have this curl, the request URL, and our response. Here's our response body, our response headers, and successful response. So basically, we declare once the types of parameters, body, etc. as function parameters. We do that with standard modern Python types, and we don't have to learn any new syntax or methods or classes of a specific library. It's just standard Python. So we'll be going into even a more complex example when we build our to-do application.
FastAPI's combination of speed, ease of use, and powerful features make it an excellent choice for building the backend of our FarmStack application. As we progress through the tutorial, you'll see firsthand how FastAPI simplifies the process of building a robust, high-performance API. Next, we'll cover the basics of React. React is a popular JavaScript library for building user interfaces, particularly single-page applications where you need a fast, interactive user experience. Here's some key features of React. It has a component-based architecture. React encourages the development of reusable UI components which manage their own state and can be composed to build complex UIs. Virtual DOM. React uses a virtual DOM to improve performance. When the state of an object changes, React updates the virtual DOM first, then it efficiently updates the real DOM to match. Declarative UI. React makes it easy to design interactive UIs. You design simple views for each state in your application, and React will update and render just the right components when your data changes. JSX. React uses JSX, which is a syntax extension that allows you to write HTML directly within JavaScript. This makes the code easier to understand and debug. To start using React, you need to have Node.js and NPM, Node Package Manager, installed on your machine.
You can create a new application with the following command. We have npx create React app, my app. Note that it's also very common to create a React app with Next.js, which instead of doing create React app, you would do create next app. So that's a very popular way to create a React app. But for now, we'll just use this create React app. And this is going to create a new directory called my app with all the necessary files and dependencies. So now in the terminal, we can change directory into my app. And then if I just do npm start, it will start the development server and automatically open the default web browser to display the React application. So here it is. Here's the React welcome page. So let's just do a very quick review of this project structure. Now, this is not a React tutorial, so this is going to be pretty brief here. We have the public tutorial where it's going to contain static assets like the index.html, which is the main entry point for the application. And then we have the src folder, which is where you'll write most of your React code. So like index.js is the JavaScript entry point that renders your React application into the root element in the public.html file here. So we can see this root element, and that's where the JavaScript is going to send all your React application, basically. Additionally, we have the app.js, which is the root component of the React application. So the index.js is going to send our app.js to the index.html to make sure our web page shows correctly. So now let's create a basic React component just so you can have a very brief overview of React components. So inside the src folder, I'm going to create a welcome.js, and then we'll just put this code here. This just defines a functional component called welcome that takes a props object as input and returns a JSX element, which is basically like HTML within a JavaScript file, and this displays a personalized greeting. So now let's see how to use this component that we just created. So I'm going to go to the app.js, and I'm just going to delete everything that's already in there so we can do something a little simpler. We're going to import React, then we import the component that we just created. Now it's just going to return this, and see, this is how we access a component. And it's going to use the welcome component to render different names, 3 different names. So let me just save that. And we can see it says, hello Alice, hello Bob, hello Charlie. So we just put in the welcome component, hello, and then the name 3 different times. So just really quick, I want to talk about state and lifecycle. I'm going to do one more example. This will be called clock.js. And React components can also manage their own state. So this is an example of a class component to demonstrate the state and lifecycle methods. So we have the class clock, extends component, and we have the constructor where we're going to get the date, which is what we'll use for the clock. And then we have the component did mount, component will unmount. These are basically functions that get called at different parts of the lifecycle. And then we have a custom function tick that will be calling here, this.tick, to tick the clock forward. So basically the clock component sets up a timer when it is mounted and clears it when it's unmounted. And the tick method updates the component state every second, causing the component to re-render with each new time. And then it just gives the HTML or the JSX that's going to appear on the page.
React is a powerful library for building dynamic and interactive user interfaces. Its component-based architecture, efficient rendering with the virtual DOM, and declarative nature make it a popular choice among developers. As you become more familiar with React, you can explore more advanced topics like hooks, context, and performance optimization. Next, we'll learn more about MongoDB. MongoDB is a popular NoSQL database designed to handle large volumes of data and provide high performance, scalability, and flexibility. Unlike traditional relational databases, MongoDB stores data in flexible JSON-like documents. This document-oriented approach allows for the storage of complex data structures in a more natural and intuitive way. In MongoDB, data is stored in collections, which are similar to tables in relational databases, but without a fixed schema. This means you can have documents with different structures in the same collection. This flexibility is one of the key advantages of using MongoDB, especially when dealing with unstructured or semi-structured data. Let's take a look at an example of a MongoDB document. Imagine we have a collection called users that stores information about users in an application. Here's what a typical document might look like. In this document, we have various fields such as name, email, age, and address. The address field itself is an embedded document containing multiple subfields like street, city, state, and zip. Additionally, the hobbies field is an array of strings.
While this looks like JSON, MongoDB stores data in a binary format called BSON, or binary JSON. BSON extends the JSON model to provide additional data types, such as integers, floats, dates, and binary data. This binary format is optimized for performance and flexibility, allowing MongoDB to efficiently store and retrieve data. Another important feature of MongoDB is its ability to scale horizontally. This means you can distribute your data across multiple servers, making it easier to manage large data sets and ensure high availability. MongoDB also supports rich queries, indexing, and aggregation, making it a powerful tool for a wide range of applications. For example, you can perform a query to find all users who live in a specific city. MongoDB is widely used in various industries, from e-commerce and content management to real-time analytics and Internet of Things applications. Its flexibility and scalability make it an excellent choice for modern applications that need to handle diverse and dynamic data. Docker is not technically part of the farm stack, but it can make running a farm stack application simpler. So in this section, I'll teach the basics of Docker and containerization. In essence, Docker is a platform that allows you to package your applications and all their dependencies into neat little containers. Think of these containers as self-sufficient boxes containing everything your application needs to run smoothly, regardless of the environment. Docker offers a bunch of benefits for developers and anyone who works with software. First, consistency. You can say goodbye to the dreaded "it works on my machine" problem. Docker ensures your application runs the same way everywhere, from your laptop to a cloud server. Isolation. Each application runs its own isolated container, preventing conflicts and dependencies issues. This means you can run multiple applications on the same server without them interfering with each other. Efficiency. Docker containers are lightweight and share the host operating system's kernel, making them incredibly resource efficient compared to traditional virtual machines. Scalability. Need to handle more users? No problem. Docker makes it easy to scale your application by spinning up more containers. And here are a few key Docker concepts. We have the Docker image, which is a read-only template that contains the instructions for creating a Docker container. It's like a blueprint for your application. Then we have the Docker container, a running instance of a Docker image. You can start, stop, and manage containers independently. And Docker Hub, which is a public registry where you can find and share Docker images. Think of it as the GitHub for Docker images. Docker Compose is a tool for defining and running multi-container Docker applications. We'll be using it in our To-Do application. Here are some elements of Docker Compose. The YAML file. It uses a YAML file to configure application services. Single command. It allows starting all services with a single command. Environment management. It can manage multiple environments for your application. And network creation. It automatically creates a network for your application's containers. In our farm stack to-do application, we'll be using Docker to containerize our FastAPI backend, React frontend, and MongoDB database. This will allow us to ensure consistency across development, testing, and production environments, and also easily manage dependencies for each part of our application. Plus, it will allow us to simplify the process of running and testing our full stack application. And we'll be able to prepare our application for easy deployment and scaling. We'll use a Docker file to define the environment for our FastAPI backend, and we'll use Docker Compose to orchestrate our entire application, including the React frontend and MongoDB database. Now I'll talk more about the to-do project we'll create and how the elements of the farm stack fit into the project. Our farm stack to-do application will include the following features. Multiple to-do lists. Users can create, view, update, and delete multiple to-do lists. Each list has a name and contains multiple to-do items. And then the to-do items. Within each list, users can add, view, update, and delete to-do items. Each item has a label, a checked, unchecked status, and belongs to a specific list. Real-time updates. The UI updates in real time when changes are made to lists or items. Responsive design. The application will be responsive and work well on both desktop and mobile devices. Our MongoDB data model will consist of two main structures. The to-do list, and here's what that structure will look like. And also the list summary for displaying in the list of all the to-do lists. And here's what that structure will look like. Our FastAPI backend will expose the following RESTful endpoints. So for the to-do list, here are the endpoints. And for the to-do items, here are the endpoints. This project will provide a solid foundation in FarmStack development and Docker containerization, which you can then expand upon for more complex applications in the future. So let's get started with the project. So let's start with setting up everything for the project. We'll set up the project structure. First, we'll create a new directory for the project, farm to do, and switch the directory. Then we'll create subdirectories for the backend and front-end section. Next, we'll set up the backend environment. So we'll go to the backend directory, and we'll create a virtual environment and then activate it. Then we'll create the files, the Docker file and pyproject.toml, which I'll be explaining more in a moment. And then we're going to install the required packages. So FastAPI, this is what we already talked about. We're installing it with the all extra, which includes additional dependencies like UVcorn for serving our application. And then motor is an asynchronous MongoDB driver for Python. We're using the SRV extra, which adds support for MongoDB's SRV connection strings. And then Beanie is an object document mapper for MongoDB built on top of Motor. It's going to allow us to define our data models as Python classes and provides an intuitive API for database operations. And finally, AIO stream or AO stream. This package provides tools for working with asynchronous streams, which can be useful when dealing with large data sets or real-time data. Now that we got those installed, we can generate the requirements.txt file. And we've already installed the dependencies, but if we still needed to do that, if you're trying to set up this project on a different computer, you can install the dependencies using pip install -r requirements.txt. Okay, now let's go into our Docker file, and we'll add the following content. So a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It's essentially a blueprint for creating a Docker container. So let's look at this Docker file. We have from Python 3 that just specifies the base image we're using. In this case, we're starting with an official Python 3 image. It gives us a pre-configured environment with Python installed. Then we have the workdir user/src/app, which sets the working directory inside our container. And then copy requirements.txt. This copies our requirements.txt file from our local machine to the current directory in the container, which lists all our Python dependencies. Then we have the run pip install, and then that whole line there. This command installs all the Python packages listed in our requirements.txt file. And the expose 3001 informs Docker that our container will listen on port 3001 at runtime. Then we have the command cmt python and the src server.py. This is the command that will be executed when our container starts. It runs our server.py file located in the src directory. With this Docker file, we're creating a reproducible environment for our application. Anyone with Docker installed can use this file to build an identical container, ensuring consistency across different development and deployment environments. Which makes me remember that if you don't have Docker installed, you're going to have to install Docker on your computer to follow along with the rest of this tutorial. And you can just kind of search up another text-based tutorial, just search install Docker, and then figure out how to install Docker on your computer. The pyproject.toml file is a newer standard in the Python ecosystem, which is introduced in PEP 5.18. It's designed to be a centralized configuration file for Python projects, which replaces many tool-specific files like FastAPI and then others like that. So this can contain configuration settings for various tools used in Python development. So in this specific one, this tool.pytest.ini options indicates that we're configuring PyTest options. So in this course, actually the testing is beyond the scope of what we're going to do, but this is just kind of setting it up for later if we wanted to introduce tests into our projects. And the Python path equals src is just telling PyTest to add the src directory to the Python path when running tests. Again, this is just setting up for if you want to add tests yourself later, and it's just kind of best practice to have this in there. Okay, speaking of the src file, let's set up the backend structure by creating an src directory inside the backend directory, and then we're going to create two files, server.py and dal.py. DAL stands for the data access layer. The DAL file is responsible for handling all interactions between application and the database, and it abstracts the complexities of database operations from the rest of the application. So let's create dal.py. I'm just going to paste in some code here. So like I said, this is going to handle the interactions with the MongoDB database. So we're first going to import some stuff. We have the bson to handle MongoDB's object ID, which is going to handle MongoDB's object ID. I already talked about motor, asynchronous MongoDB driver, and then we have the pymongo for specifying return behavior and update operations. The pydantic.base model is going to create data models with validation, and then the UUID is going to generate unique IDs. Now we're going to have a few different data models. So we're going to have the list summary, which represents a summary of the to-do list, the to-do list item, which is an individual to-do list item, and the to-do list, which is a complete to-do list with items. So each is going to have a from_doc static method to create instances from MongoDB documents. The to-do-dal class encapsulates all database operations. So you see we have a list to-do lists, and it's just going to, and this code will asynchronously yield summaries of all to-do lists from the MongoDB database. We have the create to-do list, which is going to create a new to-do list and return its ID. And you can see all this code just uses standard what you would use when you're working with MongoDB. And then we have the get to-do lists, retrieves a specific to-do list, delete, pretty self-explanatory, deletes a to-do list item. Then we have the create item, which is going to add a specific to-do list. And then the set check state will update the check state of a specific item. It's going to have to find the item, and then it will update it. And all this should look familiar if you're at all familiar with MongoDB, but if not, this is how it works. And then finally, we have the delete item to delete an item. Some key points about this file is that all methods are asynchronous using the async await syntax for non-blocking database operations. And there's also extensive use of type hints for better code clarity and IDE support. And this, you would notice that it uses various MongoDB operations like find, insert one, find one, and update. There's also data transformation, which converts between MongoDB documents and pydantic models for type safety and validation. And all methods accept an optional session parameter for transaction support. And then most methods return none if the operation fails or the document is not found. So this DAL file provides a clean type-safe interface for the rest of the application to interact with the database, abstracting away the details of MongoDB operations and document structure. Now let's implement the FastAPI server. So we'll go into the server.py file. I'll paste in this code. We're going to have these various imports up top.
for FastAPI, MongoDB, and custom modules. And a lot of these some of these are similar to what we saw in the other file. We're also going to configure variables for the MongoDB connection and debug mode. You'll see that we're using the environment variable MongoDB URI. That's going to be the MongoDB connection string, which will create an environment, a .env file with that connection string later, and I'll show you how to get that. So we start off with this async context manager, and defining the lifespan function. This function manages the life cycle of the FastAPI application. We see what happens on startup, which is going to connect to the MongoDB and initializes the to-do DAL. It's going to ensure that the database is available and get the collection, the to-do list collection. And then on shutdown, it's going to just close the MongoDB connection. Then we have the app equals FastAPI with the lifespan, the debug. This is going to create the FastAPI application with the lifespan manager that we had just defined. Next, we get to the core of this, which is the API endpoints. So we're going to the GET request to API/lists is going to retrieve all the to-do lists. Then we have a POST request to API/lists, which is going to create a new to-do list. And we're just going to pass in a name for this one, which is just the name of the to-do list. Then the GET API/list/list ID is going to retrieve a specific to-do list. Then if we make a delete request, we can delete a list. And then if we post to API/list/list ID/items, we can add a new item to a to-do list. And we're just going to pass in the item name, or we can delete an item. And we can also set a check state, if you're going to check that an item is checked. We also just have a dummy endpoint for testing. We're not going to really use this, but we're just going to put it in there for future testing. Now, throughout this, we've been seeing these pydantic models like new list response, new item response, to-do item update, dummy response. These models define the structure of request and response data for various endpoints. And then we have at the bottom, we have our main function. This function runs the FastAPI application using UVcorn when the script is executed directly. So some of the FastAPI features that are demonstrated in this file is async support. All endpoint handlers are asynchronous, allowing for non-blocking I/O operations. We also have type hinting for request and response models, which improves the code clarity and enables automatic request validation and response serialization. We also have the path parameters with the endpoints, like the API/list/list ID to capture the dynamic parts of the URL. We have the request body parsing, where FastAPI automatically parses JSON request bodies into pydantic models, like the new list and new item. We also have the response models, which are the endpoints that specify return types, which FastAPI uses for response validation and OpenAI documentation. Then the HTTP status codes, which are the custom status codes that are set for certain endpoints, like we saw the status.http 201 created for post requests. And then dependency injection, the to-do DAL instance is injected into the app and used across the different endpoints. Finally, we have the Swagger integration. FastAPI automatically creates Swagger documentation for this API. Okay, we got that out of the way. Now let's actually create our database on MongoDB. So you can go to mongodb.com, and then you can either sign in or create a new account. And then after you sign in, you can create a new project. If you're creating the account for the first time, it may go into this automatically. but you may also have to select new project. So we'll just name our project, and then we can create the project. Then we just need to create a cluster. And we can choose what type of cluster we want to create. You're probably going to want to create the free one, which is basically just for learning. If your project gets really big, you can always switch to the paid one. Then create a username and password. Note I will delete this or change the password before this video goes live, so don't worry about seeing my password. And then after creating the user, we can choose a connection method. We're going to have to wait till our cluster is all set up. But after the cluster is all set up, we can go into the connection screen again, and we can, if we click through a little bit, we can see our MongoDB URI. This is what we're going to need to connect to our database. So just copy this URI, and then we'll go back into Visual Studio Code. And now we're going to need this URI for our environment variable. So in the root of our directory, we'll create the .env file, and then we'll create a variable, MongoDB _URI, all capital letters, equals, and then we're going to put quotation marks around this and put our URI that we just copied. We're going to have to make sure that we put in our password. Again, I'll be changing this later. And then we are going to have to put in the database name. This doesn't have to exist already. It will create this database if we don't have this. So after it says mongodb.net/, we're going to put to do right before the question mark. And that's going to create our database name. Okay, now let's create our Docker compose file. This is just going to be in the root directory of our project, compose.yaml. So I'll put in this code here. This is the Docker compose configuration file, and Docker compose is a tool for defining and running multi-container Docker applications. So we are going to configure it by adding the name. Services is going to define the different containers that make up the application. So we basically have three containers. We have the nginx service, which is going to use the official nginx 1.17 image, and it mounts a local nginx configuration file into the container. And then it's going to expose port 80 in the container to port 8000 on the host. This is going to help reroute the front and the back end to the correct URLs on our site. And it's going to depend on the back end and front end services. So the front end service, this is going to just specify using Node. The user is going to set the working directory and the user in the container, mounts the local front-end directory into the container. It's going to expose port 3000 internally into the host, sets the environment variables, and then runs npm start command to start the front-end application. Then we have the backend service, which is going to use the custom image built from the backend directory. It's going to mount the local backend directory into the container, expose port 3001 internally, and map it to port 8001 on the host. It's going to run the Python server script, and it's going to use this is how we get in the environment variable file that we just created, the .env. So yeah, we just have the three main sections: the nginx reverse proxy that routes the request to the front and back end, the Node.js-based front end application, and the Python-based back end application. And this is going to basically create a consistent, reproducible development environment that closely mimics the production setup, and we can start the entire application stack with all three containers with a single command, which we'll do it later. So it's easier to develop and test full stack applications. So let's finish with setting up the nginx configuration. So we'll create a directory named nginx at the root of the project. We'll create a file named nginx.conf for config inside the nginx directory, and we'll paste in some code. So this is going to configure our nginx web server, which like I said, was used as a reverse proxy for the FarmStack application. So first we're going to define the server block. It's going to listen on port 80 for incoming HTTP requests, and then we're going to set the server name, and then we're going to create the front-end proxy, which is going to forward the requests to the root path, to the front-end service, which is going to be running on port 3000. And then we have the backend proxy, which is going to forward the requests to the /API to the backend service running on port 3001. So this will make sure the host names front end and backend are going to be resolved within the Docker network, so we can use these names instead of IP addresses. And then we have the port mapping, the API routing, the WebSocket support. So this is basically going to allow us, nginx is going to allow us to serve both the front end and back end applications from a single domain and port. And in the context of our Docker Compose setup, this nginx container acts as the entry point for all web traffic and routes requests to either the front end or back end service as appropriate. Okay, time for the front end. We are going to set up the React application, which is the front end built with React. So we'll go to our front end directory and then create a new React application using create React app. Now there's some more modern ways to create a React app with Next, but this is going to work just fine for what we're doing here. So we're going to install additional dependencies. This Axios is a popular promise-based HTTP client for the browser, and Node.js, which is going to help create the HTTP request from Node.js. And then we have React Icons, which is a library that includes popular icon packs as React components. And we are going to use some icons in our application. So now we are going to set up the main app component. So let's go over to app.js, and there's one that's already created by default, but I'm going to update it with all new code. So this is a pretty standard React application. We are going to import stuff like React hooks for state management and side effects, Axios, which we just installed for HTTP requests, some custom components that we are going to create. Then we have for state management, we have the list summaries that stores the list of to-do lists, the selected item that stores the selected to-do list. We have the use effect hook, which is going to call reload data when the component mounts to fetch initial data. And the reload data function, it will fetch the list of to-do lists from the API and updates the list summaries state. And you can see it's doing http.get API/lists. So this is going to our backend because of nginx rerouting anything that's /API to our backend of our application. Then we have the event handlers, the handle new to-do list, that creates a new to-do list, handle delete to-do list, deletes, handle select to-do list, obviously selecting, and then back to list, which is going to clear the selected list and reload data. We have some conditional rendering. If select item equals null, it renders the list to-do list component. And if a list is selected, it renders the to-do list component for that specific list. And then we have some props passing various state values, and handler functions are passed as props to child components. This app component serves as the main container for the to-do application, and it manages the overall state and orchestrates the interactions between the list view and the individual to-do list view. It handles data fetching, updates, and user interactions at the top level, and it passes necessary data and functions down to child components. So let's create the list to-do list component, which was referenced in the previous file. Let's create a new file called list-to-do-list.js, and we'll paste in some code here. It's going to start with imports, the component CSS file for styling, the use ref hook from React for creating a reference to the input element, and then here's we're gonna use the buy solid trash. This is an icon from the React Icons library that we installed earlier. Then we have a functional component, list to-do list, that's going to take 4 props. The list summaries, which is an array of to-do list summaries, handle select list. The function handles, which is the function to handle selecting a list. The handle new to-do list, which is the function to create a new list. And the handle delete to-do list, which is obviously going to delete a list. And then we have the use ref, which is used to create a reference label ref for the input field. We also have conditional rendering. So if list summaries is null, it's going to show a loading message. And if it's an empty array, it shows a message and then the form to create a new list. Otherwise, it's going to render the list of to-do lists. So we got the heading, then a form to create a new to-do list, even if you already have a to-do list, and then it maps over the list summaries to render each to-do list summary, which is gonna each list is gonna have a name, a count, and a trash icon for deleting the list. And then there's a few events. If you click on a list summary, it calls the handle select list with a list ID. Clicking the trash is going to delete it. And then the trash icon click event uses the stop propagation to prevent triggering the list selection. And you can also, like I already mentioned, create a new list. So this component is purely presentational with all logic handled via props from the parent component. And this whole component serves as the main view for displaying all to-do lists, which allows users to view, select, create, and delete lists. And as you can see, it's designed to be flexible, which can handle various states of the application data efficiently. Then we're going to create the styling for this. So we're going to create the file list.todolist.css. And this is just some really basic styling. And then we'll move on to the to-do list component. So we'll create a new to-do list.js, which is going to be pretty similar, similar imports. It's going to have the component definition, the functional component to-do list with the list ID, and the handle back button function is going to be one of the props. It's going to have some state here. And then the use effect hook, this fetches the to-do list data when the component mounts or list ID changes. And then it also updates the list data state with the fetch data. Then we have the 3 event handlers to create an item, delete item, or check the toggle if someone clicks that the to-do list item is complete. And the conditional rendering, if it's null, it shows a loading message, or it's going to render the to-do list with all the main parts of the list, including a back button. And then it just maps over the list data to items to render each to-do item. And for each to-do item, there's a checkbox, an item label, and the trash icon. And then we got the event handling. Clicking on an item triggers its check state. Clicking on the trash icon deletes the item. And then if there's an empty state, it will display the message there are currently no items. So this component manages its own state for the to-do list data. All the CRUD operations for to-do items are handled within this component, and the component is responsible for displaying the to-do list and managing the item. So it's basically a detailed view for a single to-do list. Then we're going to create the to-do list.css to style this. It's pretty basic. And let's update the main CSS file as well. We'll go to index.css, and then we'll just update the code with some basic simple styling for the CSS. So basically, we're done setting up the React frontend for the FarmStack to-do application. We created the main app component, the list to-do list component, the to-do list component, and it's basically complete. So now we're going to test it out. So in this part, we're going to run the application using Docker Compose. So like I said earlier, you gotta make sure you have Docker installed on your system. So we can open the terminal in the root directory of the project, and then we'll run Docker Compose up -- build, which is going to build and start the containers. Up means it just means it's going to create and start the containers defined in the compose.yaml file. And the -- build flag tells Docker Compose to build the images before starting the containers, even if they already exist. So first, like I said, it's going to read the compose.yaml file to understand the services, networks, and volumes defined in the application. Then for each service that has a build context specified, it's going to build a new Docker image using the Docker file in the specified directory. This happens even if an image for the service already exists, which basically means it's going to rebuild it. So once all the images are built, it's going to create and start the containers for each service defined in the compose file, and then it's going to attach to the containers and streams their input to the terminal. So now they should be up and running. We can go to the web browser
and then we're going to go to localhost 8000. So if you remember, it's actually using inside the Docker containers, it's using port 3000 and 3001, but that's being rerouted to port 8000. So let's test it out. A new to-do list, FarmStack course, and then if we click where it says 0 items, we can start adding some items. So let's just add a few items here associated with our course. And now you can see we have one of our lists is the FarmStack course 4 items. Now I'm going to create another list, a shopping list. We'll add some items to our shopping list. And you can see both lists on this page. If I click into the items, I can check them off when they're finished. Checking a few more off, I can delete some items. And you can see all that works. I can delete a list. Now let's go to our MongoDB Atlas dashboard where we set up our database. And I'll show you how you can see the data right from the MongoDB website. So let me refresh this page and we'll go to Browse Collections, go into the collection, and we can see here's the only item is the FarmStack course, and we can see the different items within this, which is an array, so we can see the different to-do items in this list. And we can even make a change right from this page. So I'm going to change this to write and edit articles. And then if I can click update here. If I go to my to-do list, and we'll see it says write and edit article. I can check and uncheck it. Okay, let me just add another little to-do list here with some items. Now I'll go back over to MongoDB Atlas, and we can see that list now appears in the list of items here. So we're done with the project.
Congratulations on completing this comprehensive FarmStack tutorial. By building this to-do application, you've gained hands-on experience with some of the most powerful and popular technologies in modern web development. You've learned how to create a robust backend API with FastAPI, build a dynamic and responsive frontend with React, persist data with MongoDB, and containerize your entire application using Docker. This project has demonstrated how these technologies work together seamlessly to create a full-featured, scalable web application. Okay, happy coding.